Hey guys, how are you? Welcome back to the channel. Today is day 26 of upskilling myself, and today I just solved two DSA problems because I had to fix the chatbot issue in my portfolio website, and also I had some internship work to do. And yeah, so let's see the DSA problems that are solved. So the first problem was remove all adjacent duplicates in a string. So we have been given a string, let's say A, B, B, A, C, A, and we have to remove these duplicates and this duplicate over here, right? So if you see, these are adjacent duplicates, right? And when we remove these double B's, the string would be AA and CA. Again, this would be adjacent ones. So we can notice a thing that we have to just remove the adjacent duplicates, right? So what we can do is we can create a stack and we can push every letter into it. So every element into the stack. And if we see the next element which is equals to the stack dot top, then we can remove these both of the elements, right? We can't consider these two. Okay. So we can either do it using the stack, we can also use vector for it, we can also use string for it, because why use so much space when you can just do it using string and all that stuff, right? Because if you do using stack, you have to then convert into string and then output the result, right? So to solve it, we first of all define a string which is temp, which is empty. Then we traverse the string, and then if the temp is not empty and the back of the temp is equals to character, so which means that if this A is already in the string, then we have to pop back from the temp and we have to return the temp as our answer. So let's say this is the string. Earlier it was A over here. Now if we see A over here again, we'll pop back this A, right? Then we insert C. Then we go over here, A is not over here, so we'll insert A and we can output this temp over here. Okay. In else condition, we have to push back the character and we have to return the temp. It's pretty easy. So the second problem is partition list. So we have been given a linked list and a value x, and we have to partition it such that all the nodes which is less than x should come before the nodes which are greater than or equals to x. And we should also preserve the original relative order. So which means that if 4 is before 3, then it should be before 3, right? And this 2, which is before this 2, should also be before this 2 over here. Okay. So to solve it, first of all we create two linked lists. So let's say linked list 1 and linked list 2, which are both empty, and this is our main linked list, so it's like 1 4 3 2 5 and 2. Okay. So now if the first element, if it is less than the x, so x in this case is 3, so if it is less than 3, then we put it in the first linked list, so it will be over here. Then 4 will be on the second linked list, 3 will be on the second linked list, 2 in the first linked list, 5 in the second, and 2 in the first linked list. Then what we do is we do the next of the end of the first linked list as the first of the second linked list. Okay. And the next of the last element of the second linked list would be null. So we have done the same thing over here. We have defined left, right, and the left tail and right tail to manage the last elements. Then we traverse the whole linked list, and if the head value is less than x, then we put it in the first linked list, else we put it into the second linked list, which is the right linked list. Then we advance the linked list, and then the next of the left tail would be the next of the right. The next of the right tail would be null pointer, and then we have to return left of next. So we have to return this over here. Okay. So for the development part, I did some internship work. I had a chatbot issue in my portfolio, so I resolved it. I did some YouTube stuff, and I did the revision of all the DSA problems that are solved till now. So thank you guys for watching, and see you on day 27.